Hello, everybody. This is going to be the very first section that we do for Chapter 1. It's 1-1. And whenever I do these videos, we're not going to go over the bell ringer and the individual work, like the team huddle and the team master that come later. We're just going to get into the bulk of the lesson and go over that for these videos, so they're a little bit shorter. So we're going to start out with today's big question in the notes. So what is the difference between an algebraic sentence and an algebraic expression? We're going to do some vocab first before we get into any math-related stuff. So sentence and expression. Some vocabulary. We have a variable. You should all know what a variable is. It's a letter that represents any kind of value. So we have all kinds of variables. The most common ones you think of is x, y, but you can have other things as well. You could even have a smiley face, right? Just some symbol that represents a number. There's all kinds of variables out there. Algebraic expression. So to be an expression, you have to have numbers with variables, and then they are combined using arithmetic. Now, what is arithmetic? That's just your basic addition, subtraction, multiplication, division. So for example, I have some examples here. What would be an algebraic expression? We could have 2 plus 5x. We have arithmetic. We have a variable in there. That's considered an expression. How about 7y minus 11z? Same thing. It is an expression. You have a minus sign. We have multiplication going on with the variables. You can have more than one variable. It's okay. And let's do one more. How about 10x over 11, let's say a. I wouldn't even have to have a variable at the bottom if I don't want to, but that would also be an expression. Now, we're going to go a little bit more specific here. Now we're going to go to an algebraic sentence. A sentence is an expression, but it uses these symbols: equals, less than, greater than, etc. in between them. So let's create an example of that. What would be a sentence? So it has to be an expression, like one of these up here. And we just have to include these things. So for example, we could say it's 5 minus 7x equals 3y. That would be a sentence. We could use one with a different symbol. Let's say 17 is less than 100. And let's do b this time. So we kind of get more specific. We start out with having an expression, and then it becomes a sentence as soon as we add these things in here. So we're going to try an example where we're actually going to be creating some expressions. Example 1, Logan has 830 songs on his iPod. He buys 12 new songs each month. If Logan continues to buy 12 songs every month, how many songs will he have after m months? So we're going to use this chart here and kind of figure out what kind of pattern we can use, so that way we can create an expression with m in it. So we're going to go down through here, putting numbers in for the months, and eventually go down to m. So the total number of songs on his iPod, well, the first month, well, before we even start, he starts with 830. So we're going to create an algebraic expression to show this, but we're adding 12 songs every month. So as soon as we start, before the month even begins here, we're going to start with 830 songs. Oh no, 830. Let me redo that. Plus, and we're going to be buying 12 songs every single month. So we're going to do plus 12 times 0, because it's the 0th month. So if you were to actually figure that out, that just becomes 0, and you get 830, which we knew because he starts out with 830 songs. Using the same logic to keep making these kind of expressions, we have 830 plus 12 times 1 that would be 842. And then we do it again. Hopefully you can see the pattern that I'm creating. 830 plus 12 times 2. Man, it's not working out so well for me here. 12 times 2. So that would be 24 plus 830, which is 854. And we'll do it one more time, going to month 3. 830 plus 12 times 3. We're just keep adding a set of 12, right? If you look over here, we just keep adding 12 to each set. So that'd be 866 songs. So the last one we're going to use is M. So where would the M go? Well, what's the variable? What's changing every single time is the number of months. So we're using M for months. So what number will be changing in here will be how we're going from 0 to 1 to 2 to 3. Everything else is staying the same. So it will always be 830 plus 12 times M, the number of months. So we wouldn't have to keep going through this and going from 1, 2, 3, 4, 5. If we said we wanted to figure out how many songs we'd have after 35 months, I wouldn't want to make a chart like this and keep adding 12. It's easiest to have an expression like this. And so if we wanted to know the 35th month, we could put in 35 here and then just solve the equation or the expression. So we're going to try another one. Very similar concept. I would suggest you trying to see if you can get it first, maybe stopping the video, and then if you can, just go back and watch it and see if it actually comes out to be the right thing. So Madison has $52 saved up. Each week she receives $10 in allowance. If she continues to save and receive an allowance, how much money will she have after W weeks? So very similar, but now we're talking about weeks. So she's saving $52 every single week. So week 0, same idea. What we start with, 52. But we're adding on no money this time because it's week 0. So we're adding on $10 times 0. And so we know that she starts with $52. Next week, same idea, 52 plus, well, 1 week has passed, so it's 10 times 1. So that's 62. Hopefully you get the idea and can fill out the rest of this pretty easily. The second week will be at 2 there. So that would be 72. Last one, since we're just adding 10, is 82 plus 10 times 3. And then for W, again, we're just replacing what's changing, and that would be the number of weeks. So 52 plus 10W. Hopefully that's pretty easy for you. So then we're going to get into, hopefully you know what this stuff is called here. Some things you might see actually on Facebook and trying to figure out if people can answer it correctly because people don't know what they call the order of operations. So we're going to go over how do we actually solve these kind of problems, and hopefully you remember how to do that. So we're going to go through each step individually on how you would actually approach a problem like this. Maybe you can figure that out now, and we'll see what it is. So we're going to go through the steps. Order of operations. Normally you're used to hearing PEMDAS. Sometimes people change it to G for YEMDAS. I think the only reason they do that is because they want to make sure you're not leaving out certain things. When you have PEMDAS using the P, that means it stands for parentheses. But in this case, we actually want to take care of more than just parentheses that you see. This is considered G for grouping. Any type of grouping symbols. So grouping symbols, what does that include? Well, it obviously includes parentheses. What else does it include? If you ever see a square root, what's underneath there? It's grouped together. What else? Absolute values are grouped together. And also fractions. The numerator is grouped together and the denominator is grouped together. So there's a lot of different grouping symbols. It doesn't just mean parentheses. Once you take care of all the grouping symbols that you can, putting things together inside the grouping symbols, then we go to exponents. Usually we do pretty well up to this point. We do our parentheses or our fractions, the top and bottom, and we go to exponents. It's not too bad. Now, it's very specific on how you do this. When we say PEMDAS, we go to M first, thinking multiplication comes first, but it does not. It only comes first if it's from left to right order. So these are actually on the same level. multiplication, and division. If that's all you have left to do, before you get to the other two, then you do it from left to right. So even if division comes first, you're going to do that first from left to right. It doesn't matter which one comes first, they are on the same level. Same thing with addition and subtraction, the last two. And subtraction. Same idea, from left to right. They are on the same level. Subtraction may come first, so you do it first. It all goes from left to right when they tie. So let's do an example. Using the order of operations, let's solve this. So the first thing is your grouping symbols, but there doesn't seem to be any grouping symbols. So we'll go right to the exponents, and there is an exponent right here. So that would be 5 squared, which is 25. So right underneath it, I'm going to simplify that and then just copy down everything else. All right, so now what are we going to go to next? Well, we did grouping, we did exponents. Now we're on multiplication division from left to right. So it looks like we have division and multiplication here. But which one comes first? Left to right, it's these two. 12 divided by 3 is 4 times 25 plus 76. Now we're going to do our multiplication because we're still going left to right, and multiplication beats addition. So we put these two together and get 100 plus 76. Now we put these two together to get 176. I would just keep writing up the steps as you go down, only doing one specific thing at a time until you get the final answer. 4. Now we do have grouping symbols, so we can put these two together. A lot of people like to look at this problem and try to distribute. We do not distribute, especially when you don't have variables, because the only reason we have distributive property to begin with is if something inside here cannot be put together. But you can put these together because they're not just variables. They're like terms in a sense. You can put them together. So 6 divided by 2 can be put together to get 3. And what you have between these two is multiplication. So you don't need the parentheses anymore. You can just put times if you want. Now what do we have left? We would be on the multiplication division since there are no exponents. So where do we have multiplication division? It'd be right here. So we're going to do 5 times 3, or negative 5 times 3. So it's 17 minus 15 plus 3. And now we have addition, subtraction, but we're going from left to right. We do not add first. It's whatever is from left to right. So we're going to start over here. 17 minus 15 comes first. That's 2. Bring down the rest and add them together. You get 5. Hopefully that's not too bad. We're going to go to something more difficult now. Well, we only have like 1 or 2 examples left. So we're going to try order of operations, but now we're going to do some substitution. So this is part of something called the quadratic formula. You may or may not have seen this before, but what we're going to be doing is looking at these letters and changing them out with the numbers. A is 3, B is -1, C is -4. So that's what I'm going to do first. Put B in, put A in, put C in, change these all to numbers inside there. So negative B, which would be negative, see what B is? It's -1. It's going to be -1 minus the square root B squared. Make sure you put that in parentheses, the -1 squared, minus 4 times what's A? 3 times C, which is -4. And the bottom is 2 times A, which is 3. Okay, now that we have it set up, let's talk about where our PEMDAS or GEMDAS is. The square root is all considered a grouping symbol, so we can do everything inside the square root. Also, grouping is all the top and all the bottom of a fraction. So let's work with this. We know that negative and a negative turns to a positive, so we can put that to 1. But then we're going to work with inside the square root. Inside the square root, it's a grouping symbol, so we have to work with inside there. So nothing else is grouped together, but we can do these parentheses / exponent, -1 squared. That will come first, so you get a 1, because it's negative 1 times negative 1. And then we have minus 4 times 3 times negative 4 all over. The bottom is also considered a grouping, so we can put them together and get 6. All right, so we have, whoops, not that. We only have 1 on top. 1 minus the square root. Now here all we have inside is multiplication. We have negative 4 times 3 times negative 4. So that's 1. You can do them individually if you want. It's up to you. This becomes negative 4 times 3, which is negative 12, times a negative 4, which is a positive 48. So all I did here was just multiply all 3 of those together. Bottom is still 6. So we have 1 minus the square root. Add them together, you get 49 over 6. Square root of 49 is a nice number. So we have 1 minus 7 over 6, which equals, top is negative 6 over 6, or negative 1. Got to be one little nice answer. All right, last thing we have here is some more vocab. Okay, to be an equation, specifically, it's a algebraic sentence. So it has numbers and variables and arithmetic. And the only thing it has to have specifically, it's not just one of those random symbols like less than, greater than, equals. It has to specifically be an equal sign. That's where they get the word equation. It almost spells the word equal. It's just missing the L. So it has to have an equal sign somewhere in the middle of it. So for an example, we talked about this before. Y equals 5x minus 7. That would be an equation. What about 10 plus 4 x equals 11x? That would be an equation as well. As long as you have an equal sign, we have arithmetic, we have variables, we have everything we need. It's okay. They can all be part of making an equation, as long as you have the equal sign in the middle here. And then you have a formula, which is even a little bit more specific. So it's an equation, just like we just did up here, stating that an algebraic expression is equal to only one single variable. And you must have a variable on each side of the equal sign. Let me give you an example. One formula we did talk about, I was thinking about writing earlier, was y equals mx plus b. We have multiple variables, but it's only equal to 1 on this side, the y equals part here. Let's do another one. You might know some other famous formulas, like I'm trying to think. You could do A equals L times W, area equals length times width. That would be a formula. You can make up your own thing. You could say it's x equals, let's say 3r plus 7t. That would also be a formula. You have a variable on one side. You have to have a variable on both sides, but specifically one side has a variable all by itself. That makes a formula. So I think we only have one more example. Example 6, state whether the following is a formula. We're just going to write yes or no and kind of talk about why it is or isn't. So we're saying whether it's a formula. So that's the one we just went over. One of these things. It has to be one of these kind of things here. So does it have a variable by itself? Sure does. Is there variables on the other side? There sure is. Yes, it is. A equals pi r squared. R is a variable. A is also a variable. It's all by itself. Yes. Y equals 2x plus 7. That looks a lot like one we had earlier. Y equals mx plus b. It is a variable, or is a formula. Yes. And they can also be equations. I mean, these are all also equations, but to be more specific, it's also a formula. So it's kind of weird in how they kind of nest inside each other. Number 4, There's a variable on each side, yes, but there's not just equal to one variable, so this would not be a formula, although it is still an equation. And the last one is an x by itself on this side, but there's no variable over here, so no. And that should be everything you need to do the rest of the problems, because you have the huddle to do. So you have some of these problems to do on your own. There's 4 there, and then on the next page there's more problems to do as well. So you can try them yourself to see how you do. I'm not going to spend time going over them. So until next time, we'll see you later.